All right, so we're talking about promises. Promises are the best, and we're going to have two separate workshops on them. Let's see, Google Drive, instructor materials. Just grabbing the deck here. Immersive, junior phase, practical promises. Where's that? MISC. There it is, JSO 300. Okay, good. I got it. Practical Prolonged Process Programming, a Prompt Promise Primer. No, I did not write the title. All right, so what is a callback? A callback is a function to pass to another function. So it's like the function in a higher order function. There are blocking and non-blocking callbacks. Callbacks don't have to be about async. Some people call callbacks just generically any function that you provide to a higher order function. Some people restrict the word callback to only mean asynchronously called functions. So here's more of a general theory of functionality. Here are examples of blocking callbacks. These are synchronous callbacks. They're callbacks that are fired off right away, and then as they're running, like nothing else happens, and nothing happens in between. So if we're filtering an array using a predicate function, predicate functions return true, false, indicating whether we are collecting those elements and including them in the filter or not. So if you're not used to array filter, I could do something like an array of string, number, number, string, string, number, number. And then I could say array.filter, a function that takes an element and returns if type of element equals string. And that function, it will be called for every element in the array. And for every element of the array for which the function returns true, this will pop out an array with just those elements. So for each is a function that loops through an array, passing the element into every function, and you just do something with it. Map is an array function that calls the function on every element of the array and generates a new element. So you get a new array with new elements. Filter is a function that loops over every element of the array and picks some of them out to generate a new array with just some of the elements. All of those are example of blocking callbacks. In other words, functions which are immediately invoked by this higher order function. Filter immediately starts calling this predicate function. Map immediately starts calling the iterator transformer function. Sort immediately starts calling the comparator function. No delay there. Non-blocking callbacks happen in asynchronous land. So when a click happens at some indeterminate point in the future, run this handler. In Express, when a request comes in, pass the request into this middleware function. When I'm reading a file in Node using read file, after you finish reading this file, call this function with the data. So these are examples of callbacks that happen asynchronously. Some of them just receive data because there's no possibility of them failing. It's like a click handler doesn't fail. It either you clicked the thing or you didn't. Whereas reading a file might fail if that file doesn't exist. So sometimes we have these node-style error backs, which are asynchronous callbacks that have an error first. So a function passed to another function. When it comes to non-blocking functions, we have event handlers, middleware, and vanilla async functions. And vanilla async functions are where we start to get a lot of difficulty with control flow and composing multiple asynchronous results together. People who don't know how to do multiple asynchronous things simultaneously and wait for them all to finish, that's pretty tricky. What about do an asynchronous thing, and once that's done, do this other asynchronous thing, and once that's done, do this other asynchronous thing? That's also potentially tricky. Sequential versus parallel, multiple things and waiting for them, etc. So here's a lovely little set timeout. We got this result, and this is an example along the lines of what we've seen a lot of times before. we know that because Node queues up this function to run in the future, that first this console log runs, which means result starts out as undefined. And it doesn't get set to hello until after the console log. So that's not the proper way to do sequential actions with async. This is another pattern that a lot of people start out trying to use. They call an asynchronous function, and then they try to return a value from inside the callback. And then they try to assign a variable equal to the result of calling the higher order function. Well, that doesn't work. This inner function, the callback, hasn't even run yet. So there's definitely no way that set timeout, which is a separate function entirely, could return the string hello. If this function here, the callback, hasn't run, set timeout can't possibly know what its return value is. So that also doesn't work. So once something is async, the results have to be handled inside the callback. There's no way of getting around that with normal JavaScript-y kind of stuff. Once it's async, the results must be handled within a function. So what is a promise? And why is that different? And how is it that we can return from an asynchronous function? Promises represent, in an abstract way, eventual values. A promise is like this, it's an object. Let's start off straight from the start. It's not a special language construct. It's not any one of a number of things. It's an object. Promises are objects. Promises are objects that do not yet have their value. Think of the promise like a mailbox. You can move, or like an inbox on your desk. You can move the inbox around, but it might not have any papers in it yet. Maybe somebody promised that they're going to put a paper in the inbox. So it's this box that could have a value, but it doesn't necessarily have the value yet. And you can, because it's an object, you can move it around places and you can store it as a variable. But then how do you actually use the value? How do you actually use the value? Well, the promise object that you get, in order to use the value, you can't escape the fact that in async land, you have to handle the results inside a callback function. So promises are actually built on top of callbacks and give us a different way of using callbacks rather than passing the callback straight to the higher order function. The higher order function is not even a higher order function. It's a primitive. It takes a primitive value and it returns a promise object. And that promise object has a .then method, which can take callbacks. So this is super similar, right? Like, okay, so here we've got a read file that takes the value and a callback function. Here we have a promiseified read file that returns an object that has a then that you can give callback functions. That feels like it's worse at first. It's like, well, wait a second. How is this better than this? You've got two functions here, one for success and one for error, whereas here we had one function for possible error and possible success. And here we just had, well, call the function and then give it the callback. Whereas here we have to call the function, call then, and give it the callback. So that's weird. We're going to see why this is 50 billion times better shortly. Okay, so how do we use these things? We can't do this. This is a callback, so we can't, this thing is going to run asynchronously in the future, the success function. So we can't do this. We also can't say do promisify whatever .then and return because we're still stuck in async land. So we can't get it back out into this scope. That's just not possible. So it still is not going to work this way either. We can have a result and we could set result to hello, but we have to handle the result inside the callback. So far, it's weird. It's like, why would we have this alternative way of registering callbacks? Well, let's see reading a file for a second. Promises are all about mimicking synchronous code and making async code look more like synchronous code. So in synchronous code, I can have a path to a file. I can try to read the file synchronously using Node's fsReadFileSync. This fsReadFileSync, by the way, if the path is a bad file path, it will throw an error. So if it throws an error, try catch, catches the error, and then you could do something with the error, like console error it out. If it doesn't throw an error, then we'll get this result and we'll console log out the result and we'll use it. And synchronously, then after all this work is done, we could say, oh, and then do this last thing. With vanilla callbacks, we do an fs read file that might receive an error and might receive data. So already we have an issue where you have to write the error first, and this line becomes really long because you have to define a new function. And then you have to remember to say, if there's an error, do this, else do this. And then you can omit the else if you put a return keyword here, but that's also kind of ugly. So it's like, you're getting the idea. And look at this, I am first and I am last are kind of flipped around. Like this is gonna run, and then I am last is gonna run because it's the end of the callback. Okay. Here's the promise version. We run this promisify read file. It gives us back a promise object. We call then on it for success, and we have another function for error. If the promisify read file succeeds, this function will run, and we'll use the results. If the promisify read file fails, this second function will run instead, and we will use the error and do something with it. Once we are satisfied that we've handled the result or the error, we could do another .then. Oh, this is interesting. Promises allow you to chain thens, which means we can describe our asynchronous effects in a more sequential manner. And we could say, once this is finished, do this instead. And regardless of whether we ended up in here or ended up in here, after those are finished, it'll come out and we'll end up in here. Now we still have this issue of this runs first because these are callbacks and they're going to run at some point in the future. Now promises, because when I call this function, it returns a promise object instead of taking in a callback, this actually returns something and I can store it as a variable. That's interesting. Now I've broken apart the place where I start my async and the place where I decide what to do with the results. Those are now two separate lines of code, completely separated from each other. And that means that not only can I decide what to do with the promise here, I could throw the promise into another module and decide what to do with it over there. I don't have to give a promise a callback right away. I can give the promise to somebody else and they can give it a callback. So in my Twitter.js, my getAllTweets function now returns a promise. And over here in my route where I called getAllTweets, that's where I tell the promise what to do with the results. Instead of me giving a callback function to this getAllTweets, getAllTweets gives me back a way to attach callbacks. But I could also export this from this module and require it in other modules, and all of those modules could use the same single asynchronous result, and they could all say what they want to have happen once that async is done. Because I can just use this promise object in multiple places, and I can give it multiple callbacks. I can give it multiple callbacks. That's what this slide is showing. If I have a promise object, I can say over here in this part of the code, hey, promise object, when you're done reading the text, log out the contents. And then somewhere else in my code, I can also say, oh, and by the way, promise object, when you're done reading the text, remove this file from the file system. Unlink means like, basically is destroy, but it's like remove the symlink. So I can, in multiple places of my code, use this async result without having to worry about remembering calling functions that call other functions which call other functions. I could just have a reference to the object and I can refer to it multiple times and I can establish handlers on it in multiple places. The really awesome part is when I want to chain asynchronous results. So I could do this. This is the bad way of doing it. I could say, Go read a file, return a promise. I'll tell you what to do with the results. And when you have the results, I just read a file. Go read another file, returns a promise, and I will tell you what to do with the results. And now we start to have callback hell again, right? We're nesting callbacks inside of callbacks. We're not going to do that. We're going to do this. This is where things start to become super magical. I'm going to do this async action. Read the file. Returns a promise. We tell the promise what to do with the results. We're just going to log, I read file 1. Then in this callback, we start reading the second file. So we don't start reading the second file until we've read the first file. You see that? This line, promise if I read file 2, doesn't happen until read file 1 has finished. But now, instead of embedding the callback inside of this handler, so we start getting nesting, I just return this promise from inside the callback. That should probably feel really weird to you, because I've emphasized so many times that you can't return values from callbacks. With promises, you can. The promise objects listen to the return values of their callbacks and automatically handle the sequential action composition and wait. They automatically wait for this promise to fire and finish before this next callback runs. So inside a callback function in a promise, if you return a new promise, it waits on that promise before calling the next callback function. And now we can compose sequential actions just by saying return a promise. Then once that's done, the next callback runs. Return a new promise. It waits. Once that's done, it'll do the next callback. Return a third promise. It waits. Once that's done, it will do the next thing. And you could just keep going down the line like that. Remember how with all of the vanilla style callbacks in the post, I had to do, if there's an error, call the callback with the error. If there's an error, call the callback with an error. If there's an error, call the callback with an error. Over and over and over again. Here's the second magic trick that promises do. I can put a single error handler at the bottom of the chain, and it automatically counts as an error handler for everything above it. So .then as a function takes two callbacks. It takes a success callback and an error callback. If I put a single error callback at the bottom of the chain, if this fails, or if this fails, or if this fails, it doesn't matter which one fails, it'll skip everything and come back into this callback at the bottom. One error handler for the entire line of callbacks.
On that point, how, like, that seems almost like a bad thing, because what if you have three different things, like three different errors that you want to log, like you wanted three different error statements to describe each function?
Then you can manually decide to opt into having error handlers for each of them.
Okay.
So you still have the ability to do separate error handling for each of them. In practice, we almost never want that. In practice, we usually are just satisfied with saying, look, either this chain works or it doesn't work.
Okay.
So we can pass promise objects around and use them in multiple places. Multiple pieces of code can all wait on the results of a single promise and use those results when they're available. We can compose sequential actions, asynchronous actions, as a flat chain with a descriptive return promise, return promise, return promise. And we have unified error handling with a single catch at the bottom. There are lots of promise libraries that people have written that conform to this A+ spec. We are going to use the Bluebird library in the workshop. I wrote this one, but that's just a fun fact. Okay, so that is the lecture on promises. We're going to start using the promises tomorrow in the workshop. And also tomorrow morning, I'll do like a small bit of demo, but I want you to like go and digest and think about that and do the pre-reading and stuff like that before we get back to that. Let's take a short break, and then we're going to do the senior panel. So come back at 6:40. Any questions before I stop the recording? Okay, see you at 6.